In most scenarios, connecting two wires to a single 110-volt circuit breaker within an electrical panel is not permitted. Circuit breakers are engineered to safeguard a specific quantity of wires and a defined amperage. Connecting multiple wires to a single breaker can result in an overloaded circuit, posing a significant fire hazard. Breakers are rated for a specific number of conductors, typically only one. Exceeding this design limitation compromises safety and could lead to overheating and failure. There are exceptions to this rule, although they are highly specific and require careful evaluation. One instance where it might be acceptable to connect two wires to a single breaker is if both wires are of the same gauge, meaning they possess the same current carrying capacity, and the cumulative amperage of both wires does not surpass the amperage rating of the circuit breaker. For example, if you have two 14-gauge wires, and the circuit breaker is rated for 15 amps, it might seem acceptable. However, even in this scenario, it is crucial to verify the compatibility of the breaker with multiple conductors. Many breakers are not designed to securely hold two wires under a single terminal screw. Attempting to do so can lead to loose connections, which are a primary cause of electrical fires. Furthermore, even if the amperage seems within limits, other factors come into play. The length of the wires, the type of insulation, and the ambient temperature all influence the wire's ability to safely carry current. Overloading a circuit can cause the wires to overheat, potentially melting the insulation and creating a short circuit or fire. To determine whether it is safe to connect two wires to a circuit breaker, it is always necessary to seek guidance from a certified electrician. Electrical work can be extremely dangerous. Firstly, working with electricity carries the risk of electric shock, which can cause serious injury or even death. Secondly, improper wiring can lead to electrical fires, which can cause significant property damage and endanger lives. Thirdly, electrical codes are complex and constantly evolving. A qualified electrician has the knowledge and experience to ensure that electrical work is done safely and in compliance with all applicable regulations. An electrician can assess the specific situation, taking into account all relevant factors such as wire gauge, amperage rating, breaker type, and local electrical codes. They can also determine if the breaker is designed for multiple conductors or if an alternative solution, such as installing a new circuit or using a tandem breaker, is more appropriate. There are several reasons why simply adding another wire to an existing breaker is a bad idea. One reason is that the breaker might not be designed to handle the extra load. Circuit breakers are designed to trip when the current exceeds the breaker's rating. This is to protect the wiring from overheating and causing a fire. If you add too much load to a circuit breaker, it will trip more often. This can be annoying, but it can also be dangerous. If the breaker trips repeatedly, it could eventually fail. If the breaker fails, the wiring could overheat and cause a fire. Another reason why doubling up wires is a bad idea is that it can make it difficult to troubleshoot problems. If there is a problem with the circuit, it can be difficult to determine which wire is causing the problem. This can make it more difficult to fix the problem and can increase the risk of an electrical fire. A better alternative to doubling up wires is to install a new circuit breaker. This will provide a dedicated circuit for the new load and will help to prevent overloading the existing circuit. If you are not comfortable installing a new circuit breaker yourself, you should hire a qualified electrician to do it for you. In some cases, it may be possible to use a tandem breaker. A tandem breaker is a type of circuit breaker that allows you to connect two circuits to a single breaker slot. However, tandem breakers are not allowed in all electrical panels. You should check with a qualified electrician to see if tandem breakers are allowed in your electrical panel. If you are considering doubling up wires on a circuit breaker, it is important to weigh the risks and benefits carefully. In most cases, it is not safe to do so. It is always best to consult with a qualified electrician to determine the safest and most appropriate solution for your specific situation. When considering electrical modifications, safety should always be the primary concern. Shortcuts or improper wiring can have severe consequences. Firstly, carefully consider the load requirements of the circuit. Adding additional devices or appliances to an already heavily loaded circuit can easily lead to overloads. Secondly, ensure that all wiring connections are secure and properly insulated. Loose connections or exposed wires can create fire hazards and increase the risk of electric shock. Thirdly, regularly inspect electrical panels and wiring for any signs of damage or wear. Promptly address any issues such as frayed wires, cracked insulation, or corroded connections. When dealing with electrical systems, it is always best to err on the side of caution and seek professional assistance when needed. Ignoring potential problems or attempting to perform electrical work without proper training can have devastating consequences. Remember that electricity is a powerful force that must be treated with respect. If you are unsure about any aspect of electrical work, do not hesitate to call a qualified electrician. Their expertise can help ensure that your electrical system is safe, reliable, and compliant with all applicable regulations. Furthermore, local electrical codes may have specific regulations regarding the number of conductors allowed under a single terminal. These codes are designed to ensure safety and prevent electrical hazards. Ignoring these codes can result in fines, penalties, and potential liability in the event of an electrical incident. Therefore, it is crucial to be aware of and comply with all applicable electrical codes in your area. If you are unsure about the specific requirements, consult with a local electrical inspector or a qualified electrician. In addition to the electrical code requirements, manufacturers of circuit breakers also specify the number of conductors that can be safely connected to their breakers. These specifications are typically found in the product documentation or on the breaker itself. It is essential to adhere to these manufacturer specifications to ensure the breaker functions as intended and provides adequate protection. Violating these specifications can void the warranty and increase the risk of electrical failure. Connecting two wires to a circuit breaker that is not designed for multiple conductors can create several problems. One problem is that the wires may not be securely fastened to the breaker. This can lead to loose connections, which can cause overheating and arcing. Another problem is that the wires may not make good electrical contact with the breaker. This can reduce the amount of current that the breaker can carry, which can lead to overloading and tripping. In addition, the wires may be damaged when they are bent and twisted to fit under the breaker terminal. This can weaken the wires and make them more likely to break. Using a wire connector, such as a pigtail, to combine the two wires into a single wire before connecting it to the breaker is not a safe solution. While this may seem like a way to avoid doubling up wires on the breaker, it does not address the underlying issue of the circuit's capacity. The combined current of the two wires may still exceed the breaker's rating, leading to an overload. Additionally, the wire connector itself must be properly sized and installed to ensure a safe and reliable connection. Using an undersized or improperly installed wire connector can create a fire hazard. Instead of trying to find a workaround, it is always best to address the problem correctly by installing a new circuit breaker or using a tandem breaker if permitted. This will ensure that the circuit is properly protected and that the electrical system is safe. When hiring an electrician, it is important to choose a qualified and experienced professional. Check their credentials, licenses, and insurance to ensure they are qualified to perform electrical work in your area. Ask for references from previous clients and review their online reputation. A reputable electrician will be able to assess your electrical needs, provide sound advice, and perform the work safely and efficiently. Do not hesitate to ask questions and express any concerns you may have. A good electrician will be happy to explain the work they are doing and address any questions you may have. Remember, electrical safety is paramount, and it is always best to seek professional assistance when dealing with electrical systems. Furthermore, it's important to understand the difference between a neutral wire and a ground wire. The neutral wire carries the return current from the circuit back to the source, while the ground wire provides a safety path for electricity in the event of a fault. Never connect a neutral wire to a ground wire or vice versa, as this can create a dangerous situation. The neutral and ground wires should only be connected at the main service panel. Mixing up these wires can cause electrical shock hazards and equipment damage. In addition to proper wiring techniques, it is also important to use the correct type of wire for the application. Different types of wire are designed for different uses, such as lighting, receptacles, and appliances. Using the wrong type of wire can create a fire hazard or damage the equipment. Always refer to the electrical code and manufacturer specifications to determine the appropriate type of wire for the specific application. For example, non-metallic cable, commonly known as Romex, is typically used for residential wiring, while conduit is used for commercial and industrial applications. Furthermore, the size of the wire, or its gauge, must be appropriate for the amount of current it will carry. Using an undersized wire can cause it to overheat and potentially start a fire. The electrical code specifies the minimum wire size for different amperage ratings. Always consult the code and manufacturer specifications to determine the correct wire size for the circuit. In addition to wire size and type, the insulation of the wire is also important. The insulation protects the wire from damage and prevents it from coming into contact with other conductive materials. The insulation must be in good condition and free from any cracks or damage. Damaged insulation can create a shock hazard or cause a short circuit. Always inspect the insulation of wires before working with them and replace any damaged wires. Another important aspect of electrical safety is proper grounding. Grounding provides a path for electricity to flow safely to the ground in the event of a fault. This helps to prevent electric shock and minimize damage to equipment. All electrical equipment should be properly grounded, including appliances, lighting fixtures, and receptacles. The grounding system should be regularly inspected to ensure it is functioning properly. Finally, it is important to be aware of the dangers of water and electricity. Water is a good conductor of electricity, and contact with water can significantly increase the risk of electric shock. Never work with electricity in wet or damp conditions. Always dry your hands before touching electrical equipment and avoid using electrical appliances near water sources. If electrical equipment comes into contact with water, immediately disconnect it from the power source and have it inspected by a qualified electrician. In conclusion, doubling up wires on a circuit breaker is generally not permitted and can be dangerous. There are limited exceptions, but it is always best to consult with a qualified electrician to determine the safest and most appropriate solution for your specific situation. Electrical safety should always be the top priority, and it is essential to follow all applicable codes and manufacturer specifications.